Hi, this is the recording for my final project, and I will be going through my IPython codebook. At first, I import the packages and tools that I will be using, including NumPy, Pandas, Matplotlib, and Seaborn for visualization, some packages from sklearn for preprocessing, including min-max scaler, standard scaler, and the models and layers from Keras. Initially, I import the train data as well as the test data, and showing here are the first 5 rows of the respective data sets. And then I start working on some exploratory data analysis by visualizing the data. Here is a very high-level multivariate line chart showing the line charts for all 14 variables. And this is some of the additional exploratory graphs that I did as well. Here is the line chart, but this is only showing the temperature, which is our target variable. And you can see here, the x axis I label year over year from 2009 to 2014. And the last visualization that I created is the correlation matrix. So because I wanted to see if there's any strong, whether positive or negative correlations between the variables. And you can see here that RHO has the most correlations with many variables, and they are all negative correlations. Next, we are at data preparation, and here I'm borrowing the function from a website, Machine Learning's Mastery, that was recommended by Professor in order to reframe the training data set. Here I have a control switch because I want to switch between using min-max or standard scaler. I load in the train data set again, and then if it's 0, it means I'm using min-max. If it's 1, it means I'm using standard normalization. And here the function series to supervised was used to reframe the train data set with 24 input, observation input, meaning for the 24-hour step, time step, and 1 output is for the 25th hour prediction of the temperature that we want to build the model to predict. After using the function to reframe the data set, I removed the unneeded columns because we only want the temperature column, the temperature predictions. I also initially I did not split the training data into training and validation set. This is something I did after I run a few models, but I'm also including this in my final submission for the IPython notebook. And here I'm reshaping the both the training and the validation set. No, I'm splitting the input and output. So X train, Y train, X valid, and Y valid. And here I'm reshaping the training and validation set. And I'm doing this For test set, I didn't have to do much because it was formatted pre-processed to be Keras ready. So all I had to do was reshaping it to the format of with shape samples, timestamps, and features as shown here. Moving towards defining and fitting the RNN recurrent network models. This is my initial model, which turned out to be my best model. Unfortunately, the experimented models did not show improvement compared to my initial model, which consists only of one layer of long short-term model layer with 50 nodes and one fully connected layer as output with one node. And for loss function, I use mean absolute error, and for optimizer, I use ANOM, and for performance metrics, I use mean square error. And I ran the model with 50 epochs. Batch size is 30, and we don't shuffle the data because it's a time series data, so we don't want to randomize the input. And here it's showing that I'm using the validation data that eventually I started to use, not initially, but after I have worked on some initial models. And you can see that my models, it seems like there's some overfitting trend here as the training data set has lost lower compared to the validation data set at after about 20 epochs. And this is my other experimented models, which unfortunately did not show any improvement. And finally, I save the prediction I call predict on test set, and I save the prediction to a CSV file, and I submit it to Kaggle. Thank you. This is the end of my recording.